The next topic is expression for frequency of emitted radiation. Expression for frequency expression for frequency of emitted radiation. So suppose this is nucleus, electron is revolving, okay, and let's say there are two orbits. So when an electron jump from one orbit to other orbit, either it will emit electron or it will absorb either it will emit radiation or energy, or it will absorb radiation or energy, okay. So if it absorb energy, then it will move to higher energy level, and if it radiate energy, then radiate or emit, okay, same. If it emit radiation, then it will go to lower energy, because if it emit energy, then it will lose energy, so if it lose energy, then its energy decreases, so it cannot be on that energy level, okay. So these orbit are also called energy level, okay, energy level. This is first energy level, second energy level, third energy level, and so on. So we have to find the frequency, okay, expression for frequency of emitted radiation, so h mu, this is frequency, okay, not velocity. So this is h mu means energy, E equal to h mu, right? So this much amount of energy is emitted or absorbed, okay. Now in this case we will consider on emitted, emitted. So when it emit, then emit means the electron is in higher energy level. So when it emit radiation, so that means it will go to lower energy level, so how much energy is released? So let's say this is E2, here the energy is E2, and in this state we need E1 energy, okay. That means this E2 is greater, right? E2 is greater than E1. So in order to be in this stage, the electron has to emit some energy, so that it will reduce its energy and it will go to this E1 energy level, so that means h mu amount of energy should be released, okay, should be emitted out. So this h mu is equal to this energy minus this energy, 1. So okay, here I will use EI minus E final, okay. Initial I for initial, F for final, so initially the electron is in this two state, E2 state, okay, and after releasing energy or emitted energy, it goes to E1 state. So E1 is the final, okay, or you can write in this case, it is E2 minus E1, h mu equal to E2 minus E1, initially it is in second state, and then after releasing energy it goes to E1 state, so initial, final. Okay, in general you can write EI minus EF. If you write 1 2 then you will confuse. Okay, so now in our previous video we have found the formula for energy of electron, right? So what is the formula? This is the formula, right? Huh? So H mu equal to, so EI. So now in place of this N, you can write I, or Ni. You write Ni. Okay, Ni. Yes, we can write Ni. Ni initial. Okay, so what is what minus 1 by 8? Minus 1 by 8. Minus 1 by 8. Z score E4M. Z score E4M. Z score E4M. E4M. E naught score N score H score. E naught score N score H score. So this is, okay, now N is Ni, you write Ni. Okay, because it is for I orbit, nah? Minus, or you can write 1 2 also, it's okay. But I prefer IF. Okay, so next is, this is minus, nah? Minus, this minus I'm writing here. Okay, or you just rub this one. So minus EF. EF is 1 by 8. Z score E4 M divided by E naught score. Now here for EI we have Ni, nah? So for EF we will write NF. NF score H score, because N is the only variable. Okay, the other, all the other are constant, nah? So this will become minus 1 by 8. Z score E4 M. E naught score Ni score H score. So minus minus plus, nah? Plus 1 by 8. Z score E4 M. E naught score N score H score. Here NF. Suffix N. Okay, don't write in the same line. Okay, now I can write this first, nah? Minus this one. Okay, because since here we have plus, so I will write the plus one first. 1 by 8. Z score E4M. E naught score NF score H score minus 1 by 8. Z score E4 M divided by E naught score MI score H score. Now all these are same. Okay, except Ni, NF and Ni, nah? This is F final, so we can take common, right? So 1 by 8. Z score E4 M. E naught score H score 1 by NF score minus 1 by, this is N. Okay, N. Ni score. Okay, this constant, this is all constant, right? This constant is called Rydberg constant. Okay, denoted by R. RYDBERG. Oh, we have this one also, nah? I forgot this one. H mu. Okay, this is not R. Okay, now this frequency and this H, this frequency we have to find frequency, nah? So H you have to take in that side. Okay, so it will be in the downside, right? 1 by 8 E naught score. H score is there, so if you bring this H also, then it will become H cube, nah? Z score E4M 1 by N F score minus 1 by N initial score. Okay, here we can write mu equal to C by lambda, nah? In class 11 we have studied in wave chapter, right? In the last chapter, C by lambda, or this can also be written as C into wave number. Oh, this is not arrow, okay? This is bar only, bar. So here lambda is wavelength, mu bar is wave number, and C is velocity of light. So this wave number, again we can write 1 by lambda. Okay, this is the wave number formula. So this frequency, we can write frequency C by lambda or C mu, or okay, let me just C mu C by lambda equal to C mu this is equal to this one, and this part is called R. Okay, R means RY Rydberg constant. Okay, RYDBERG constant. RYDBERG. So this value, if you put all this E naught, H cube, H, E, M, all this value, if you put all this value, then you will get R equal to 1.097. R equal to 1.097 into 97 into 10 to the power 7, 10 to the power 7 per meter inverse. R into 1 by N final, final score minus 1 by N initial score. Final or initial? Yes, final and initial. So this is frequency. So this is the frequency of emitted radiation.